Problem 44 of the Chapter 5 review asks, states the following: a particle moves along a line with velocity function v of t equals t squared minus t, where v is measured in meters per second. Two questions are given: find the displacement and the distance traveled by the particle during the time interval from 0 to 5. So we're looking at time on the interval of 0 to 5. Now this function t squared minus t, we're talking about a particle moving along a line, and the function t squared minus t takes on negative values for a while, and then it begins to take on positive values. So the particle, whatever the particle is doing, if it starts out here on the line, its first motion, because of the negative velocity, is to the left. It slows down, stops at the time associated with a velocity of 0, and then it begins from that point forward to move to the right with greater and greater speed. So we have a particle whose motion is to the left and then turning and moving to the right. If we want to find the displacement, we're merely interested in the difference between its position at time 0 and its position at time 5. So displacement is in essence the net change in position, and it's found by simply integrating over the entire interval the function that's given. So in this case, t squared minus t dt. That produces 1/3 t cubed minus 1/2 t squared from 0 to 5. At 5, we get 5 cubed, which is 125, so we have 125 times 1/3 minus 5 squared is 25. 25 times 1/2 is 25 halves. And from that we need to subtract, so this is my value at 5. And from that I need to subtract the value at 0, but the value at 0 is 0. Combining the two fractions, we have a common denominator of 6. And our numerator will be 250 minus 75, which is 175 divided by 6. The units of this, because our dt is time in units of seconds, our velocity is in units of meters per second, we have meters per second times seconds, and so our units of measure is meters. What does this tell us? It tells us that the particle ended its motion 175/6 meters to the right of where it began. It did move farther than that because it initially moved to the left and then moved back to the right. But we'll take a look at that in the second part of this question, which is the question of distance traveled. The distance traveled question, total distance traveled, requires one of a couple of different approaches. One is that we consider its motion from the time it begins to the time it stops. And then if that motion, if the integral of that is negative, we convert it to a positive to indicate that we want a distance. We don't want a directed distance. And then add to that the distance that the function moves to the right. So it requires that I take a look at the function itself and determine where that function is equal to 0. That is, where did the velocity, graphed on the y-axis, when, I guess is a better question, when did the velocity, at what time, did the velocity change from a negative velocity to a positive velocity? And from this function we can see, just by factoring, we can see that the velocity changes at time equals 1. So to evaluate this, what we're really looking at is the following. We're looking at the integral from 0 to 5 of the absolute value of the function t squared minus t dt. But that's accomplished by breaking the integral into two parts, 0 to 1 of t squared minus t dt plus the integral from 1 to 5 of t squared minus t dt. And if either of those parts is negative, I'm going to convert to a positive. So I'm going to take the absolute value of each of those integrals. What this ends up with is it will end up with me measuring the distance of the motion to the left, measuring the distance of the motion to the right, and adding those two results together. You'll recall from the earlier part of the problem, this gives me 1/3 t cubed minus 1/2 t squared. And I need to do that from 0 to 1 and add to that and take the absolute value of it, because that'll be the motion to the left. Oh, no room to write that. Plus the same thing, this is going to be troublesome, 1/3 t cubed minus 1/2 t squared, this time from 1 to 5. Running through the values of those, which I'll let you do on your own, we end up with an answer of 59/2, and that will be in units of meters. Now if you compare the answer to this one to the answer to the previous problem, you'll notice that 59/2 is a greater answer. And that makes sense again because in the first answer we were getting this distance as our answer. Just the motion from, or just the change in position from where the particle started to where the particle finished. In the second problem, in the distance problem, we added the distance to the left to the distance to the right. And so this answer will typically be larger, could be equal if all the motion was to the right, but it will be either equal to or larger than the displacement of the object.